Okay, Algebra 1 fans, our topic for today, this is notes section 3-3, rate of change and slope. Objectives after this lesson, we should be able to use the rate of change to solve problems, and we should be able to find the slope of a line. Before we begin, let me give you your joke of the day. What do you call a bee that comes from America? And the answer is a USB. Okay, so the concept of slope, this is a really important topic that you will see in every high school course. We're going to start by calculating slope basically by counting. The symbol we use for slope is the lowercase letter m. So m represents the slope. Now, we talk about slope as what we call the rate of change. It is the change in the y values divided by the change in the x values. But you may have also heard of it described as the rise over the run. Okay, now let me explain what that is. I think students tell me often that they have trouble with slope, that they don't like slope. And I think part of the reason is that we don't really understand what we're talking about. Let's say that you're working a job. And let's say your job pays you $10 an hour. Okay, you're making $10 an hour. And let's say that I'm going to graph this. And so we're going to graph 1, 2, 3, 4, 5. Let's say that our x-axis is the number of hours. And let's say that the y-axis is the money that we make. Okay, and I'll count here. I'm not going to count by ones because, we make 10 bucks an hour. So let's do this, 4, 5. Let's count by tens. Okay, 10, 20, 30, 40, 50. So if you make $10 per hour, for every hour you work 1 hour, you make $10. If you work 2 hours, you would make $20. 3 hours is 30. And notice that as I graph this, that you're getting this linear pattern. Okay, you're getting a line. So you're taking the number of hours, and each time you increase 1 hour, you are going up $10. Well, when you say what your wage is, how much you're making, you're really talking about the rate of change. $10 for every hour that you work. That is the rate of change, and that is basically what slope is. If you're driving and you're talking about your speed, for example, you're traveling 60 miles per hour, mph, or if you're in another part of the world, maybe you're going 100 kilometers per hour, kph. This is the rate of change. You're going 60 miles for every 1 hour, or 100 kilometers for every 1 hour. Here you're making $10 for every 1 hour. Okay, so the concept of slope, yes, we kind of memorize rise and run. You go up or down, and then you go right or left. But the concept is the rate of change. How quickly we change in the y direction divided by how quickly we change in the x direction. That is slope. Okay, so in numbers 1, 2, and 3, calculate the slope of each line by counting the rise over the run. Well, in number 1, here's line A, and they give us 2 points. The rate of change is my vertical change, my up and down, which is what we call the rise, divided by the horizontal change, which is what we call the run. Now, I always start, I have 2 points. I can go from either point, but I always start from the left. So in this case, I have to go up, and I would count 1, 2, 3, and when I go up, it's positive. And then I run to the right, 1, 2, 3, 4. And that is also positive. my slope for line A, I'll write it here, m equals 3 over 4. Slope is a fraction. We write slope as a fraction. Okay, it's not an ordered pair. It is not 3 comma 4. That is not correct. That's totally different. Slope is telling me the rate of change. It's the vertical up and down change divided by the horizontal left and right. Okay, now line B, I'll pick a different color here. Line B is this. We have 2 points here and here. Now again, I'm going to start from the left point. In this case, rise is up and down. So for here, I would go down 1, 2, 3, 4, 5, 6. But when I go down, it's negative. And then I run to the right, 1, 2, 3, which is positive. So m equals negative 6 over 3. Now the thing about a fraction is we always have to reduce. So that's negative 2 over 1. Or you could just say, in this case, negative 2. Now you might be saying, but wait, Mr. Cavell. What if I had started at this point? Okay, well I would have gone up 1, 2, 3, 4, 5, 6, which is positive. And then I would have run to the left, 1, 2, 3. But left is negative. So if I start from here, I go up and left. So that would be 6 over negative 3. But that's still negative 2. So it is the same. It is your choice. But for me, I will always start from the left because then I always have to run to the right. My bottom number will always be positive, and I don't have to worry about this. So here I went up and right, here I went down and right. Okay, so you try number 2, pause the video, and we'll see if we agree. Okay, for line C, here's my 2 points. I'll start from the left. We'll go down 3, negative, right 1, which is positive. So m equals negative 3 over 1, which is just negative 3. Line D is here. Here's the 2 points. We'll go rise 2, up 2 is positive. Run 1, 2, 3, 4. So m equals 2 over 4. Now that reduces to 1/2. Always reduce fractions. Now number 3, we have 2 special cases. We have a horizontal line, which is left and right, and then we have a vertical line, which is up and down. Now here's the thing with horizontal. Let's say I pick 2 points. They didn't give us points. I'm going to do this. To go from here to here, I would not rise at all. I would stay where I am. So the top value would be 0, and then the run would be positive 2. 0 divided by anything is 0. If you take your calculator and you divide this, you will see that you get 0. Now for line F, I'll pick 2 points. And if I start here, I would rise 2. That's the top value. But I would not run. I'm already there. I wouldn't move left or right, so that is 0. Now, if you type this on your calculator, you're going to get an error. So what we say is that this is undefined. So when we have a horizontal line, the slope is 0. But when we have a vertical line, the slope is always undefined. One way to remember this is if I pronounce this, horizontal has a 0 slope. Vertical line, undefined. Kind of rhymes. Okay, so to summarize what we got here, a positive slope, we're always thinking left to right. A positive slope is going to look like this. That will always be a positive value. A negative slope from left to right is going in a downward direction. A 0 slope is always horizontal, but an undefined slope is a vertical line. So the nice thing is you can look at lines and you can immediately determine positive, negative, 0, undefined. Now to get the exact values though, we count. rise and run. So number 4, calculate the slope of each line on the coordinate plane. So we've got, let's see, G, H, J, and K. G, H, J, K, so I'll write these down here, G, H, J, K. So line G, that's vertical, so right away we know that M is undefined. Vertical line is undefined. Line H, I would go down 2, which is minus, right 3, which is positive, so M equals negative 2 over 3. Line J is down here. That's horizontal. That's automatically a 0 slope. We don't need to count that. Line K is here. I'll start at this point. We'll go up 1, 2, 3, 4. That's positive. And we'll run to the right 1, 2, which is positive. And 4 divided by 2 reduces to 2. There's your slopes. Number 5, calculate the slope, the rate of change from each table. Well, the rate of change is the change in the y values divided by the change in the x values. So let's look at the y values. To get from negative 6 to 2, and from 2 to 10, 10 to 18, and 18 to 26, do you see a pattern? Hopefully you look at that and you say, oh, each time I am adding 8. And then the x value, so the slope is the change in y. Okay, I'm actually going to write this down. So each time the y values change, positive 8. Now let's look at the x values. So we go from 3 to 5, 5 to 7, 7 to 9, 9 to 11. Each of those is up 2. So it's 8 divided by 2, which is 4 over 1, or just 4. That's your slope. In part B, actually, I'm going to make a slight change to this because this should say, I'm going to go from 3, I apologize here, to 1, and from 1 to negative 1, or else it's not going to work out very well. Okay, so the change in the y values, 7, 5, 5, 3, 3, 1, 1, negative 1. Each time we're going down 2. So the change in y is down 2, that's negative. And the change in x, 8 to 12, 12 to 16. Okay, so this is plus 4, plus 4. So the change in x is positive 4, but we can reduce that fraction to negative 1/2. And that is the end of part 1.